usually do. Okay, you will have access to all of them because there's more than just the 5 kind of sets that we've done. Right? We're going to kind of spend today doing some of the old stuff. Tomorrow we'll do some of the old stuff, and then we're going to move on. My goal is to try to get up through 5.2 this week, okay? And then 5.3 part of 5.4 next week. Right? We really have to finish the chapter 5, and then we have 3 days of statistics, and that's it for the year. Okay? So we're really, really close. But it's important that we see this stuff. It's not that it's 100% necessary to do AP Calc, but it's important that we see it. Where it affects is it affects when you go to the second year calculus class. Those of you that are sophomores. All right. So we had all those identities from before, right? Good old reciprocals, quotient, sine over cosine is tangent. We've seen all that stuff before. We're going to use it a whole bunch of times. Okay? I added in like 400 slides. Check that out. Okay. Let's see long presentation. That's just don't say. Okay. There we go. Okay, so we've got our reciprocals. Got our quotients, we've got good old Pythagorean. We know up on the pink sign that they've been rearranged, right? So we have all the different rearrangements up there, but those are the 3 basic Pythagoreans. Okay? So we're going to use all of those different identities, try to do some solving. We've done this before. We've done this solving in another way. We did use right triangles to do it. There's nothing wrong with the right triangles. When it comes time for the test, as long as you show me you're using your trig knowledge and not copying your neighbor's paper, I don't care if you do it with the identities or you do it with right triangles. Okay? But I'm going to show you the identities technique, so you've got another thing that you know you can use. Okay? Alright, so the first thing I usually do is identify which quadrant I'm in. Okay? What do we know about the secant? Negative. So which quadrants is secant negative in? Third, and what else? Second, right? Secant. Negative. Alright, and then what is this saying about the tangent? Positive. So out of these 2 quadrants, which one is tangent positive? Third. So I want all my answers to reflect quadrant p values. So meaning the signs have to reflect quadrant. Okay? Alright, so I've got to get the other 6. I've got to get 6 total. I've got secant. What do I get for free? Cosine. Whatever variable they give you, keep that variable. You don't change the variables. It's a matter of when it comes time for about a year from now, you're going into calculus, and you're trying to get ready for the AP test, you don't want to change stuff on the graders. Okay? So you want to just be consistent with whatever's there. You can handle it U instead of X. Okay? Alright. Now I've got to use my identities, because that's the technique we're going to use our identities to try to get the other 4. Okay? So let's look up at the pink sign. I'm going to start with the Pythagorean. I know I can relate sine and cosine together because I've got a formula for that, right? Sine squared plus cosine squared equals 1. That's number 1 Pythagorean identity, right? So I kind of abbreviate the letters a little bit, at least when I'm trying to kind of write it out the first time. Then I put my actual trig functions in there, okay? So I'm solving for sine, right? That's the one I don't have. So sine squared u plus, what's the cosine? Negative 2 over 3 squared equals 1. Alright? Alright. So, what's negative 2/3 squared? (4/9). I know I'm in math analysis, I know I'm gonna have to subtract that to the other side, right? So what am I gonna rewrite this as instead of 1? 9. here's where the quadrant comes in. Technically, it's plus minus, right? But in quadrant 3, should sign be positive or negative? So we're only going to use the negative sign. So sine of u equals negative square root of 5. What's the square root of 9? 3. All right, what do we get for free? We get cosecant for free, right? So cosecant of u is going to be the reciprocal. And our favorite thing to do, right, rationalize. Alright, what am I still missing? Tangent, cotangent, right? I could take, because I have the secant, right? I could use my 1 plus tangent squared equals secant squared Pythagorean identity. Perfectly good way to do it. But I also know that the tangent is equal to the sine divided by the cosine, so I can use that. There's going to be more than one way to get to all. Okay? So, let's do this one. Alright, so tangent of u equals, what's the sine value? Good, and then the cosine value is double negative is going to go positive, okay, and then what's our other nice little piece of that? The 3's cancel, so I get square root of 5 over 2, and my cotangent, what do we do? Look, the reciprocal, rationalize, right? Okay, that's probably the longest example we've got to do. The first 4 are a little bit on the longer side, but the rest of them, the last, like, we're going to go to 11, the last, like, 5. Alright, so my goal for the rest of the lesson is to try to get through using the identities, but how to do it the least amount of work possible. Sound good? Okay. So, and I'm going to show you, like, remember, I can do these multiple different ways. I did not have to solve this one all that way. Okay? I just have to pick an identity that works and follow the rules. Okay, so there's going to be some things. I'll eventually show you a tangent backwards, where we use it to solve for a sine or a cosine, so you've got that. Okay? So you can avoid using that. Alright, let's look at example 2. Good news, they gave me 2 values, right? They give me 2, that means I get 2 for free, doesn't it? Okay, so that's kind of a nice thing. I still, before I do that though, I'm going to try to identify my quadrants so I make sure my signs are all correct. So what sign do I have for secant right now? Positive, so am I going to put quadrants as sign, or sorry, secant positive? 1 and 4. So for nothing else, we should know this much. Right? Okay, I got a negative tangent. Is tangent negative in quadrant 1 or quadrant 4? 4. So I know that all my answers have to be quadrant 4 answers. Okay? But yeah, that's not really part of the problem. It's for myself, so I know, hey, I'm getting the signs correct. Okay? It's a way to check. What number's technically in the denominators here? Always a 1. What do I get for free from secant? Cosine of theta is 1/2. Good. What do I get for free from tangent? Cotangent. All right, this one isn't quite as tricky, right? Have to rationalize it. So negative square root of 3 over 3. All right. So from what I have, what do I have left to find? Sine and cosecant, which I really only need one of them, right? Because I get the other one for free. All right, let's try to find a sine. What could I use that would relate sine to any one of those other identities? What formula? Up in the right place. Let's see the next one. Is there a way I can relate cosine to sine? Yeah. What do I use? Okay, I can do that one. All right, so Rebecca's using the last Pythagorean on the first row, right? Sine squared equals 1 minus cosine squared. Is that okay to use? do your arithmetic. Doesn't matter which order you do it. Okay? So let's use this one. It works perfectly good. So sine squared theta equals 1 minus, what's my cosine? 1/2 squared. Sine squared theta equals 1 minus, actually I don't want to write the 1. What's 1/2 squared? 1/4. Why don't I want to write the 1? What do I want to make it? Yeah, I'm trying to do the least. Right? I'm lazy. I know you're equally as lazy. Alright, so what's 4 over 4 minus 1 over 4? 3/4. Alright, how do we undo the square? Square root. And really, identifying quadrants is really for this right here, right? So when we take a square root, we need to know if we're going to do the plus or the minus. If we're in quadrant 4, is sign positive or negative? Negative, isn't it? Alright, so we've got sine of theta equals square root of 3 over, or negative square root of 3 over what? 2. Okay, the square root of 4 is 2. Alright, and for free we get what? Cosecant from that. So cosecant of theta, we're going to flip it, rationalize it, right? You're still confused on the rationalized step. Right? At this point, it should be second nature. Who knows? Maybe you'll get to rationalize something in the S part. I can't tell you. I know you're going to see explicit and recursive. See that? See the unit circle you're doing. Okay. Unit circle you're doing concepts. All right, we give it example 2. Okay, so good example 3. I can make this one even a little bit shorter. Okay. All right, so let's check. Let's work on our quadrant first. All right. So I know my cosecant is negative, but quadrant is cosecant negative. I think I heard somebody say 3 and 4. All right. Okay, and then tangent positive in which quadrant of those two? 3, right? It's not always going to be a 3 and 4. Those are what just happen to pop up on my examples. Okay, but it could be any of them. Right, so I know I need quadrant 3 answers. If I'm starting with cosecant, what do I get for free? Sine. Good. So we're going to do sine. Sine of theta equals negative 1 over square root of 2. And what do we need to do with that? Rationalize it. So you've got negative square root of 2 over 2. Okay. What do I get for free from tangent? Cotangent, and the reciprocal of 1 is 1. All right. What do I still need to find? Secant and cosine. Does it matter which one I find first? You see how nice that number 1 is? That would be really nice to work with, especially if I have to go use a Pythagorean, right? Way better than using negative square root of 2 over 2. Okay? So I want you to go up there. I need either a secant or a cosine, and is there a Pythagorean I can use for one of those? Based off of either tangent or cotangent. Good, I like it. Everybody hear it? 1 plus, so it's the second formula down on the pink side. Okay? 1 plus tangent squared equals secant squared. Alright, so 1 plus, what's my tangent value? 1 squared. See how nice that is? Equals secant squared theta, right? Let the laziness set in. It's okay. We want the path of least resistance to get to the right answer. Alright, what's 1 squared? Plus 1 is 2. Okay, how do I undo the square? And again, here's where our signs come in off the quadrants, right? In quadrant 3, is secant supposed to be positive or negative? negative square root of 2 over 2. Good news, we have one more that has this one. In other words, switch identity. Alright. Almost more so than the last few. If I were just looking at those numbers of 5, 12, 13, aren't I thinking right triangle numbers? Yeah. So again, I could use right triangles to do these. We can totally fall back on that. And for our goal today is to practice identities. Okay? Alright. What do we know? What quadrant is sign negative in? 3 and 4 again, right? Alright. My apologies for those numbers are the same. Alright, what about cotangent negative in which one of those two quadrants? 4, right? So it's a quadrant, 4 answers on that. Okay? Alright. At least there's no square roots right now, right? What do we get for free on this awful sign? Cosecant. Alright, so we're going to flip that one for cosecant, so negative 15 over 12. What do we get for free from cotangent? Tangents. Alright, now we're going to flip that, we get negative 12 over 5. Alright, what are we still missing? Cosine and secant. Alright. So I don't care which one we use. Doesn't matter which one by birth. It's not the fractions are the fractions, right? We're going to have to deal with it one way or another. So when we find the A formula, I don't care which one, that relates either sine, but any of those four with either cosine or secant. Everybody like that one? You're going to that one probably get memorized, right? So sine squared plus cosine squared equals 1 is a good place to start. I have sine. I know it is negative 12 over 13 squared. Cosine I don't have. Cosine squared theta equals 1. Okay. What is negative 12 over 13 squared? We go positive, right? Cosine squared theta. Ooh, let's think about this before I write that 1. I know I have to move this over. What am I going to make the 1? Yeah. Okay, when I move that 1, when I subtract the 144, what do we get? 25 over 169. Do the square. Cosine in quadrant 4 should be positive or negative? Positive. It doesn't hurt to write the plus sign, right? Just so you check that off the box, right? I know I double checked to make sure whether it was supposed to be positive or negative. Alright, so your cosine of theta is supposed to be what? Which jives with the rest of our numbers, right? Alright, and then for free we get the secant, so 13 over. Okay. Alright. So we're going to revisit 2 more identities. I know that they told me there's some stuff you got to write down, so we'll let you write on your cofunction and your even and odd. So take a minute and do any writing. Then we'll talk about these, review these once again. I know some of my signs have fallen down. You ready? So we've got the funky co-function ones and then the even and odds. These were the ones, remember, that we said the sine of 60 is the same as the cosine of 30. These two things basically had to add up to 90 and we knew they had the same answer. All you're really going to look at it today is if you see this, you replace it with cosine. Okay? If you see this one, you replace it with cotangent. They don't come up very often. Okay? Even and odds maybe come up a little bit more, but again, not very often. The cosine and its reciprocal secant, remember when we have the negative inside, it disappears. All the other ones, the negative and inside moves out front. Okay, that's kind of what we're going to see those two sets of identities in play in the next two examples. We're going to kind of do a little bit more of the same. We're going to try to shortcut as much as possible. Okay? The next one, we don't have to use a Pythagorean at all. Okay? All right, so I see this funky thing. I'm saying, hey, I want to replace that guy. I come back here and I notice that it's the same as putting what? Cosine. So I'm going to literally substitute cosine of x in for it. So basically, I got cosine of x on it. All right, before I go any further, I want to look at my quadrants. Okay, make sure I've got the correct signs and I know the quadrant I'm taking in here. So cosine is positive in which quadrants? 1 and 4, okay, and then where's on those two, where's sine positive? 1. So I want quadrant 1 answers right? So that's actually nice, right? Everything's positive. Okay, what do I get for free from cosine? Secant comes for free, so I get 17 over 8. What do I get for free from sine? Oh, secant, 17 over 15. And I know you guys might not recognize it, but again, those are really good Pythagorean theorem numbers, 8, 15, 17. Okay. All right. I know, couldn't I use sine over cosine to get tangent? That's what's missing, right? Yeah, let's use that instead of having to mess with the Pythagorean. So sine, we said, is 15 over 17. Cosine is 8 over 17. Conveniently, they have the same denominator, so what happens? Cancel, so I get 15 over 8. This is a nice one. This one is test, right? Yeah. 8 over 8. Usually we don't make you do all 6 on the test, right? We say start here and we give you one that we want you to do. You might have to get 2 or 3 others to get to that one. Okay. Alright. The next one is a little bit longer than that, and I'm going to show you how to use the tangent backwards so we can avoid Pythagorean. Again, it's just another technique. Okay? Alright, so this one, before I do my little quadrant deal, I got to get this negative out of here. So on cosine, does the negative move out front or does it disappear? It disappears. So we've got cosine of x equals 2/5. And before I get too far, I am going to identify my quadrants just in case I need it later. So cosine is positive in which two quadrants? 1 and 4, okay, and then cotangent is negative in which one of those two? 4. So I want quadrant 4 answers this time. All right, cosine, what do I get for free? Secant, okay, so secant of x equals 5/2. And then cotangent, what do I get for free? Tangent, and I'm going to have to do some work here. Rationalize it. Now, watch what I do carefully. I'm going to give you a second to get caught up. Okay, so I'm seeing negative 21 square root of 21 over 2. Square root of 21 times square root of 21 is just... Don't be too eager, and I know we've trained you so well. You want to multiply those together right away and do it in your head. Don't be too eager to do that, especially the higher. Again, there's going to be places where you're going to recognize you can cancel. This is what happens to these ones. They can cancel. Okay? So I know we want to do it fast, do the arithmetic fast, but don't get too quick. Because you're going to cause yourself more pain. All right, I'm going to do this a I'm not going to use the Pythagoreans to find my tangent, or to find what is the missing sign, right? I'm going to go for the tangent one. Okay, so I'm going to show you how to use this one backwards. Again, you could go and use your Pythagoreans, it's going to work. Okay? So tangent equals sine divided by cosine. The one that I'm missing, notice, is on the numerator. I don't want to use, if I have to find cosine, I use cotangent. Okay? All right, what's the tangent? There you go. Okay, I don't know sine, that's what I'm trying to solve, right? Sine of x. And then my cosine is perfect. Okay. All right. So I want us to think about something in an arithmetic operation. Okay. Let's pretend instead of 2/5, I just had 2 in the denominator. Right now under division, how would I take the 2 to the other side? Multiply. I'm going to do the same thing. I'm under division, I'm just going to take that fraction and multiply it to the other side. I'm not doing a flip. Okay? So I'm not trying to get that fraction out of the denominator. Okay? So I'm just taking this and I'm multiplying it to the other side. So 2/5 times negative square root of 21/2 equals sine x. What happened? It was so great there. The 2's cancel. Sine x. Again, I could use Pythagorean. I'm showing you another technique, so you've got another thing in your pocket that you can use. Okay? All right, and then I get cosecant for free, right? And the good news is this is the last one. The rest of them are no number one. It sounds a lot scarier. There's one. There's something. Alright, we're good with 6. Alright, the rest of these are just a couple of lines each. So they're very, very short. So what we're supposed to do is we're supposed to take this, we're starting with this trig expression, we have to turn it into this. Basically, it's like a multiple choice question. And I gotta fix it into one of those pieces. Some rules of thumb when you're trying to do something like this. If all else fails and you don't know what else to do, try to turn it into sines and cosines. Okay? And then nothing gets, notice how none of the answers have a denominator. So if you have something that's a denominator answer, we always convert it for trig. Okay? That's a piece we see a lot in calculus happen, and that's really the only time we see something other than a sine or a cosine pop up is if I have to divide the sine or cosine. Alright, so I'm going to go for trying to turn it into sines and cosines. What's another name for secant? Sorry, cosecant. 1 over what? 1 over sine is what I can substitute in for that, right? What happens? The sines cancel, and I'm left with what? 1. Is that one of the choices I was allowed?
Yes.
Yeah. And again, this is one of those cases where we probably wouldn't be grading your final answer. We really want to see this piece in between. Okay? That's where the real meat of the problem is. Okay? Alright. Again, I'm going to try to go for sines and cosine. So, and again, trying something, starting is better than not doing anything at all and just sitting there and staring at it. Even if it's wrong. Right? So what's another name for cotangent? Okay, 1 over tangent, am I going to be able to turn the secant into a tangent to just cancel it? No, but good place to start, right? I recognize something. What's another name for cotangent? Cosine over sine. Good. Okay. What's another name for secant? 1 over cosine. Now what happens? It's kind of like doing those factoring of polynomials, right? How fun that was because we had to cross stuff out. cosine convert back into cosecant? Okay. All right, we got 3 left. And you guys get a Pythagorean on the next one. Okay, when I see things that are squared, especially things that I know relate to one another with Pythagorean identities, at least can stare at them long enough, we should know the tangents and secants go together really well. I'm going to try to substitute something in for this back part. Okay, so I want you to look it up with that pink sign. What does secant squared equal? That's a good start. Yep, 1 plus tangent squared x. What are we going to do with this negative sign there? Got to distribute it in. Why? Kind of follow what happens here, and it'll make sense why we had to use the parentheses there. Minus tangent squared x. Okay, why was that distribution so important? What happens? Yeah, we get one of the things that they gave us. Yeah, it's kind of like magic, isn't it? It's not. It's trig. You can make trig and magic as synonyms. That's why, this is why I think trig is fun, because we can replace and get something else and get it simplified. Alright, I'm going to go Pythagorean, at least on the numerator here. Okay. So I want you to look up at the Pythagorean identities. I need something to replace cosecant squared minus 1. Good, everybody see it's the middle pink sign, right? With one on the equation on the bottom. Cotangent squared x is the same as cosecant squared x minus 1. Okay? We're going to multiply that by 1 over. So all I'm doing is separating the second part off. Now, we really like it when we can cancel things, right? So can I rename cotangent so I can cancel the cosine? Cosine what? Good, and because I have the squared, I keep the squared on both the top and the bottom. Cosine squared over sine squared times 1 over cosine squared x. Good. Now what? Cancel the cosines. 1 over sine squared x. That's not an answer choice, but what is? Yeah. Go back to the reciprocal identities. Always that last step a lot of times is where you're reciprocal. Okay? Pretty much guarantee you'll see number 11 on the test. Okay? Or some version of number 11 on the test. It's a 2-line. If it's not tangent and cosine, it's going to be cotangent and sine. Okay? What's another name for tangent? Sine over cosine times cosine, and then what happens? Cancel, and I'm left with sine. You should be able to do cosine. Okay, that's pretty basic. Okay? Alright. Yesterday I did post, and it was an assignment that was for yesterday and today. Okay, so I covered both, because I didn't know how many people we would have at that point. And yesterday, I know first period got messed up because of all the AP test bubbling stuff. Okay, so we're just going to go keep that assignment from the last 2 days. Okay, so you have some time to work, a few minutes.